requirement for these pentanomials to be listed as the group in the group is that it has to have at least one line of reflectional symmetry. And what is that exactly? So to give a description, one line of reflectional symmetry is just one line dividing the figure into two equal parts or more equal parts. And the two equal parts have to be symmetric. So we can take this for instance as a square. A square has, and if we divide it by either it's diagonal right here, or it's in uh, half vertically. So if we divide it vertically, we can see that it has two equal parts when we divide it. This is part one, and this is part two. So we have two equal parts right here, and they are symmetric as well because we can just fold it over. Think of it as a paper. We can fold it over like arts and crafts, and it would be symmetric, and it will not overlap or have extra spaces. So that's what we're looking for in these shapes, and we'll go over the first. We'll go over all the shapes, and clearly number one does work because we can just cut it in half, and as we see, two symmetric parts as like in the square right here. One right here, one, and one right here. We can just fold it over, and clearly it will be symmetric, no overlapping spaces. So we can also divide it in half horizontally like that. So we can just circle this one because we know it's going to be part of the group. How many of the 12? So the second one, third one, and fourth one do not work because if you can try all you want, but we know that we cannot divide it into two symmetric equal parts. So we're gonna move on to the next row, and the next row does have one for us. We can divide it in half, and I think that's the only way, but we can divide it in half, we can fold it over, symmetric, and this is at least one line, so it fits the requirements. The next one, same as well, we can divide it into many different ways. We can for instance, we can divide it into many different ways, and for we're just gonna choose this one, and we fold it over, it works symmetric. So this is another one. This one, however, as this one trips people up because if we divide it into half, right, there's, yes, they're equal parts, but they're not symmetric because we cannot fold it over, and we cannot fold it over without overlapping. So it would kind of look like this. And if we fold it over, it would just look like this. And that's overlapping. So to be non-overlapping, it would have to be just 3 unit squares, like that. Or and to make it like that, we would have to have 3 unit squares and and like right here, like an earlier figure. So that does not work. And this one does work because we can just cut it in half and we fold it over, it's symmetric. So the next figure, we circle that up and we go on to the next figure, and the next figure can also be folded. Can be folded symmetrically because we can just cut it diagonally and we can fold it symmetrically. Just if you have a hard time remembering that it can be, if a figure can be symmetric or not by its folding across its line, you can just practice on a piece of paper and it will help you get better at that. It's a great drill for beginners. So the next two figures, as seen here, can't be folded into equal parts and symmetrically. So we're just going to keep on moving on. So to the last figure, we can once again divide it divided diagonally like that. And as we see, we can just fold it over diagonally, same as the way of the line, and it will not overlap. So we know that this one works as well. So in total, we have 1, 2, 3, 4, 5, 6, and that your answer would be D.